Hello everyone, my name is Ali Hassan and in today's lecture we will be discussing about searching in arrays. Searching in arrays refers to the process of finding a specific element or value within an array data structure. A search traverses the list until the desired element is found or the collection is exhausted. Arrays are a collection of elements of the same data type stored in consecutive memory locations. Searching in arrays is a common operation in computer science and is used in various applications such as database management, data analysis, and artificial intelligence. There are two main types of searching algorithms used to search for a specific element or value in an array. The first one is linear or sequential search, and the second one is binary search. Linear search, also known as sequential search, is a simple searching algorithm that searches for a specific element or value in an array in a sequential manner. As you can see in the animation, it compares each element in the array with the target element until a match is found or the entire array has been searched. Linear search has a time complexity of big O of n, where n is the number of elements in the array. Linear search is efficient for small arrays, but it becomes inefficient for larger arrays. In a linear search, each element of the array is compared with the search element until a match is found or the end of the array is reached. Therefore, in the worst case, when the search element is not present in the array or the search element is present at the last position or index, n comparisons are needed. Thus, the time complexity of linear search is big O of n. Linear search is efficient for small arrays, but it becomes inefficient for large arrays. This is because as the size of the array grows, the number of comparisons needed to find the search elements also grows linearly. For larger arrays, this can result in a significant amount of time for the search operation. Therefore, for large arrays, more efficient search algorithms such as binary search, hash tables, or tree-based search algorithms should be used. These algorithms have a lower time complexity than linear search, making them faster for large arrays. Binary search is a search algorithm that divides the array into two halves and compares the target element with the middle element of the array. As you can see in the animation, if the middle element is equal to the target element, the search is complete. Or if the target element is greater than the middle element, the search continues in the right half of the array. Or if the target element is less than the middle element, the search continues in the left half of the array. This process is repeated until the target element is found or the array is exhausted. Binary search has a time complexity of big O of log n, where n is the number of elements in the array. Binary search is more efficient than linear search for large arrays but requires the array to be sorted. In binary search, the algorithm divides the array in half at each step and compares the middle element with the target element being searched. If the target element is smaller than the middle element, the algorithm searches the left half of the array. Otherwise, it searches the right half of the array. By dividing the search space in half at each step, binary search can quickly locate the target element in a sorted array. This makes binary search more efficient than linear search for large arrays. However, binary search requires the array to be sorted in order to work, which can add some additional work if the array is not already sorted. In conclusion, searching in array is an essential operation in computer science and is used in many applications. Linear search and binary search are two commonly used algorithms for searching in arrays. The choice of algorithm depends on the size of the array and whether the array is sorted or not. Thank you very much. See you in the next lecture.